There is a place in the Arizona desert where the most powerful aircraft ever built go to spend their final days. No fanfare, no ceremony, no last flight into the sunset. Just row after row after row of billion-dollar machines sitting silent in the heat, wings folded, engines cold, cockpits empty. Some of them flew combat missions over Iraq. Some of them launched off the decks of nuclear carriers in the middle of the Pacific Ocean. Some of them broke the sound barrier hundreds of times before anyone even thought about sending them here. And now they sit in the dirt waiting. This place is real. It covers over 2,600 acres of land in the Sonoran Desert outside Tucson, Arizona. It holds more than 3,100 aircraft at any given time. The total value of everything parked inside its fences is estimated in the hundreds of billions of dollars. The U.S. military calls it the 309th Aerospace Maintenance and Regeneration Group. Most people who know about it call it the Boneyard. And what happens inside those fences will absolutely change the way you think about American air power. Before we go any further, take a second right now to subscribe. Over 98% of people watching this video have not subscribed. It costs you nothing, it takes 2 seconds, and it means you never miss a story like this one. Hit that button and let's get into this. Most people have never heard of this place. And the ones who have heard of it usually think of it as just a junkyard, a place where old planes go to rust. That is wrong. What is actually happening out there in the Arizona desert is one of the most strategically important, logistically complex, and genuinely fascinating operations in the entire United States military. It is part storage facility, part maintenance depot, part resurrection center, part national treasure, and yes, part graveyard. But even calling it a graveyard sells it short because a graveyard is where things go when they are finished. And many of the aircraft sitting out there in the desert heat are not finished at all. They are waiting. Some of them will fly again. Some of them will be stripped for parts that keep other jets in the air around the world right now today. Some of them will be tested, evaluated, modified, and returned to active duty in forms that would surprise even the people who originally flew them. And some of them, the ones that have truly reached the end of everything, will be carefully, methodically cut apart until there's nothing left but scrap metal. Every single one of those outcomes matters. Every single one of those outcomes is planned, tracked, and managed by a workforce that most Americans have no idea exists. So today we are going inside the Boneyard. We are going to walk those rows of silent aircraft and understand what they actually are, why they are there, who manages them, what happens to them, and what the very existence of this place says about the scale of American military power. Because when you see it in full, it is staggering. Let's start with the basics. Where is this place and why is it there? The 309th Aerospace Maintenance and Regeneration Group, which we are going to call AMARG for the rest of this video because life is short, is located at Davis-Monthan Air Force Base in Tucson, Arizona. The location is not an accident. The desert around Tucson is one of the most ideal environments on the entire planet for storing metal aircraft outdoors for extended periods. The reason comes down to 3 things. First, the climate is extremely dry. Low humidity means low moisture in the air, which means minimal corrosion on metal airframes. Corrosion is the silent killer of aircraft. It creeps into seams, weakens structural components, destroys electrical systems, and turns a perfectly functional machine into a liability without making a sound. In a wet, humid environment, an aircraft left outside without constant maintenance will deteriorate relatively quickly. In the Arizona desert, that process slows dramatically. Aircraft can sit outside in the open air for years, sometimes decades, and remain in a condition that allows them to be recovered and returned to service. Second, the ground. The soil around Davis-Monthan is uniquely hard and alkaline. It is a caliche-based surface, which means it is dense, firm, and can support the weight of large aircraft without requiring extensive paved surfaces. You can park a massive B-52 bomber or a heavy cargo aircraft directly on this ground without sinking, without surface degradation, without the kind of infrastructure costs that paved parking for thousands of aircraft would require. When you are talking about 3,100 aircraft spread across 2,600 acres, the ability to use natural ground instead of pavement is not just convenient. It is what makes the whole operation physically and financially possible. Third, the airspace. Davis-Monthan sits in a part of Arizona where the airspace is manageable, where military operations can be conducted without the congestion of major commercial corridors, and where the geography allows for the kind of sprawling ground footprint that AMARG requires. These 3 factors working together made the Sonoran Desert the obvious choice when the military began thinking seriously about long-term aircraft storage after World War II. And the operation that began there has grown into something that the people who started it could never have imagined. The history of this place goes back further than most people realize. After World War II ended, the United States found itself in a situation that had never existed in history before. The most industrially powerful nation on Earth had spent 4 years producing military aircraft at a rate that was genuinely mind-bending. During the war, American factories were producing tens of thousands of aircraft per year. The Boeing B-29 Superfortress alone was being built at a pace that earlier in the century would have seemed like science fiction. When the war ended suddenly, the military had far more aircraft than it needed for a peacetime force. The question was what to do with all of them. Some were sold off, some were transferred to allies, some were simply scrapped, but military planners were already thinking ahead. The Cold War was beginning, the Soviet Union was not going away. The American military was going to need the ability to scale back up quickly if the strategic situation demanded it. That meant keeping aircraft rather than destroying them. And if you were going to keep them, you needed a place to keep them that would not eat them alive. Davis-Monthan, which had already been established as a military airfield during the war, became that place. In 1946, the Army Air Forces began sending aircraft there for long-term storage. When the Air Force became its own independent branch in 1947, it inherited the facility and began expanding the mission. Over the following decades, the operation grew, more aircraft arrived, more services were added. The mission expanded from pure storage to include maintenance, parts recovery, and ultimately the full regeneration pipeline that exists today. By the time the Cold War was in full swing, AMARG had become a critical piece of American military readiness, and it has remained that ever since. Now let's talk about scale, because you need to understand what 2,600 acres and 3,100 aircraft actually means in physical terms. 2,600 acres is roughly 4 square miles of land. If you stood at one end of the facility and started walking toward the other end, it would take you a significant part of your day to cross it on foot. From the air looking down at the facility, what you see is almost incomprehensible. Perfect straight rows of aircraft stretching as far as the eye can see, fighters lined up wingtip to wingtip, bombers parked in their own designated areas, cargo aircraft, their massive fuselages dwarfing everything around them, sitting in sections organized by type and status, helicopters in their own rows, trainers, tankers, patrol aircraft, electronic warfare platforms, every category of military aviation represented in some form somewhere in those rows. The organization is meticulous. Each aircraft in the facility is tracked by a detailed inventory system. Every machine has a record. Every record contains the aircraft's history, its maintenance status, the condition of its airframe, its engines, its systems, what parts have been removed from it, what condition the remaining components are in, and what its designated future disposition is. Nothing in that facility is just sitting there forgotten. Every single aircraft has a status, a category, and a plan. That level of organization across more than 3,100 machines is itself a remarkable administrative achievement, and it is what separates AMARG from the idea of a junkyard that people sometimes carry in their heads. The workforce that manages all of this is predominantly civilian. AMARG employs roughly 550 people, a mix of civilian government employees and military personnel. These are aerospace maintenance technicians, structural engineers, logistics specialists, program managers, and support staff. Given the scale of what they manage, 550 people is a remarkably lean workforce, and it reflects the efficiency that the desert environment enables. Because the aircraft do not require the constant active maintenance that they would need in a humid, corrosive environment, the workforce can focus on specific tasks rather than fighting a constant battle against deterioration. When an aircraft arrives at AMARG, it goes through an intake process. The aircraft is flown in or transported, and if it can no longer fly, and it is assessed. Depending on its condition and its designated category, it then goes through a preparation process for storage. This preparation is thorough, and it is critical to what happens next, because the way an aircraft is prepared for storage determines whether it can be successfully recovered years or even decades later. The preparation process for long-term storage is called cocooning, and the term is more literal than you might expect. Aircraft destined for long-term storage are sealed. The process involves spraying certain openings and vulnerable components with a vinyl-based preservative compound. Engine intakes are covered, exhausts are sealed. Cockpit openings and transparent canopies are treated with a protective coating that reflects solar radiation, preventing the heat buildup that would degrade internal electronics and environmental systems. Flight control surfaces are pinned in position to prevent movement and wear. Landing gear is inspected and treated. Internal systems are drained, purged, and in some cases charged with inert gas to prevent internal corrosion. The result of this process is an aircraft that can sit in the desert heat and survive for years while remaining in a condition that makes recovery possible. And the key word there is possible, not guaranteed. Recovering an aircraft from long-term storage is not simply a matter of removing the covers and starting the engines. It is a significant maintenance undertaking. But the preservation process means that when the decision is made to recover an aircraft, there is something worth recovering. Without it, years of desert storage would still cause enough degradation to make most recoveries impractical. AMARG divides its aircraft into categories, and understanding those categories is understanding the real function of the place. The first category covers aircraft in short-term storage. typically meaning they are expected to return to service within a relatively brief period, perhaps because they are undergoing modification, waiting for a fleet-wide system upgrade, or held while a programmatic decision is being finalized. These aircraft receive lighter preservation treatment, and they are tracked with higher priority for recovery. The second category covers aircraft in long-term storage, the deep inventory of machines that are being held against future need. These could be aircraft that a specific foreign ally has expressed interest in purchasing, aircraft that could be returned to service in a surge scenario, or aircraft that are being maintained in storage, while a final disposition decision is worked through the system. These receive the full cocooning treatment and are tracked carefully but without the immediate recovery urgency of the first category. The third category covers aircraft that are being used as a source of spare parts. These aircraft are not expected to fly again. Their value now lies entirely in the serviceable components they contain. Engines, avionics, structural components, hydraulic systems, control surfaces, landing gear assemblies, every part that can be removed in a serviceable condition and returned to the supply chain has value. And in many cases, the parts removed from aircraft in this category are the only thing keeping operational aircraft flying somewhere in the world right now. The fourth category is final disposition, which means the aircraft is being prepared for controlled demilitarization and disposal. The useful components have been removed. What remains will be cut up and the materials will be sold as scrap or processed according to applicable environmental and regulatory requirements. This is where aircraft truly reach the end of the line. Let's talk about what it looks like when an aircraft arrives at AMARG for the first time, because there is something genuinely remarkable about that moment. Many of the aircraft that arrive here are not broken-down machines. They are airworthy jets that were pulled from active service not because they failed but because the force structure changed around them. A fighter squadron is deactivated. A wing transitions to a newer aircraft type. A congressional decision reduces the authorized fleet size. And suddenly, aircraft that were flying combat air patrols 6 months ago are landing at Davis-Monthan and being walked into the storage rows. Pilots who have flown these jets for years sometimes accompany the aircraft on those final flights. Some of them have written about what that experience is like. You fly a jet that you know intimately, that you have pushed to its limits in training and in combat, and you bring it here and you walk away from it. The aircraft does not break down. It does not crash. It just stops, it parks, and you leave. Several pilots who flew F-14 Tomcats to AMARG after the Navy retired the type in 2006 described the experience as genuinely emotional. The F-14 was an extraordinary aircraft with an extraordinary history, and the decision to retire it was driven partly by cost, and partly by the fact that Iran, which operated the same aircraft, could potentially benefit from spare parts remaining in the American inventory. To prevent that, the Navy made the decision to destroy the parts rather than allow them to circulate, which meant the F-14s at AMARG were designated for demilitarization rather than long-term storage. The aircraft that carried Maverick and Goose across the silver screen, the aircraft that flew combat patrols over Iraq, the aircraft that represented naval aviation's apex for 3 decades was cut up in the Arizona desert. Some of those cockpit sections and nose assemblies were preserved and donated to museums, but the aircraft themselves were gone. That decision and that outcome tell you something important about the way AMARG operates. It is not a sentimentality operation, it is a strategic one. Every decision made about every aircraft in that facility is driven by military need, national security considerations, financial analysis, and treaty obligations, not by the emotional resonance of a particular airframe's history. Now let's talk about the aircraft themselves, because the variety of machines inside AMARG at any given time is a comprehensive history of American military aviation from the jet age forward. Walk those rows and you will see F-16 Fighting Falcons, arguably the most successful multi-role fighter aircraft ever built, produced in the thousands and operated by air forces around the world. Some of the F-16s at AMARG are there because the Air Force is transitioning to newer variants. Some are there because foreign customers are being processed for foreign military sales. Some are being stripped for parts to support operational F-16 fleets in countries that still rely on the aircraft heavily. Walk further and you will see A-10 Thunderbolts, the ground attack aircraft that has survived more attempts at retirement than perhaps any other aircraft in Air Force history. The A-10 is beloved by the Army soldiers and Marines whose lives it has protected in combat, and the arguments over its retirement have played out in Congress and in the Pentagon for years. Some A-10s sit at AMARG while that argument continues. They are in a kind of institutional limbo, preserved against the possibility that the retirement decision will be reversed, or that specific airframes will be needed to keep the operational fleet at required strength. You will see B-52 Stratofortresses, the remarkable bomber that has been in continuous service since the 1950s and is currently projected to keep flying into the 2050s. The B-52s at AMARG are not all there permanently. Some are held against the requirements of strategic arms limitation treaties, stored in configurations that allow satellite verification of their non-operational status. Others are being evaluated for potential return to service. The B-52 fleet is a perfect example of how the Boneyard operates not just as a storage facility, but as a strategic reserve that feeds a continuously evolving force structure. You will see C-130 Hercules transports, which have been in service since 1956, and represent one of the most successful and versatile military aircraft designs in history. You will see F-15 Eagles, the air superiority fighter that went undefeated in air-to-air combat for decades. You will see older aircraft types that have been out of American service for years, but remain at AMARG because the parts they contain support foreign operators who still fly them, or because treaty obligations require their physical presence to be maintained and verified. The variety is extraordinary, and it speaks to the full sweep of jet-age military aviation history in a way that nothing else does. One of the most significant and least understood functions of AMARG is its role in international arms transfers. The United States government sells military aircraft to allies and partners through the Foreign Military Sales Program, and AMARG is a critical node in that pipeline. When a country purchases American aircraft through FMS, those aircraft frequently come from AMARG storage rather than from new production. The financial logic is straightforward. An F-16 that has been in desert storage and is then refurbished to a known standard costs significantly less than a newly manufactured aircraft, while delivering a capable and proven platform that the purchasing country's pilots can begin training on relatively quickly. AMARG has supplied aircraft to dozens of countries through this mechanism. Greece, Jordan, Morocco, Taiwan, Pakistan, Egypt, Bahrain, and many others have received aircraft that were originally in American service, passed through AMARG, were refurbished to delivery standard, and entered service with their new operators. This function means that AMARG is not just relevant to American military capability. It is a direct tool of American foreign policy and alliance management. Keeping certain aircraft in serviceable storage maintains options that diplomacy and strategy may require. A country that needs a specific aircraft type to fulfill a defense commitment to its region may be able to receive that aircraft from AMARG on a timeline that supports the strategic objective, when new production would take years longer and cost substantially more. The program managers at AMARG who track those aircraft, maintain their storage status, and coordinate their recovery and refurbishment when a sale is finalized, are doing work that has genuine strategic consequences, even if their names never appear in any newspaper. Let's talk about the parts recovery function in more detail, because this is where the economic and operational impact of AMARG becomes most concrete and most immediate. Every day, somewhere in the world, an operational military aircraft is grounded because a component has failed and the part needed to fix it is not in the active supply chain. This happens constantly. Supply chains are complex. Manufacturers sometimes go out of business or stop producing legacy parts, and the logistics systems that support military aircraft, despite being extraordinarily sophisticated, cannot anticipate and stock every possible failure mode for every aircraft in the fleet. When that situation occurs, the call frequently goes to AMARG. The facility's inventory system is queried for the needed part. If an aircraft in the storage inventory has a serviceable example of that component, a work order is generated. A maintenance technician goes to that aircraft, removes the part according to technical specifications, inspects it, documents its condition and history, packages it appropriately, and ships it. That part, pulled from an aircraft that has been sitting in the Arizona desert for years, gets installed on an operational aircraft somewhere in the world, and that aircraft returns to service. The financial value of this function is massive. Parts that are no longer in production cannot simply be ordered from a manufacturer. They have to be found. AMARG is essentially the world's largest and most organized source of exactly those parts. The facility estimates that it provides hundreds of millions of dollars in parts value to the supply chain every year. Some analyses have suggested that over the life of the facility, the parts value it has delivered to operational users has exceeded the total cost of running it by a significant margin. Which means that even if you set aside every other function AMARG performs, even if you ignored the long-term storage mission and the regeneration capability and the foreign military sales pipeline, the parts recovery function alone would justify the existence of the facility. The Boneyard pays for itself, and then some. The regeneration mission is the part of AMARG's work that captures the imagination most powerfully, because there is something genuinely extraordinary about an aircraft that has been sitting in the desert for 10, 15, 20 years being brought back to life and returned to operational service. The process of regenerating an aircraft from long-term storage is not quick and it is not cheap, but it is dramatically faster and less expensive than building a new aircraft from scratch. When a regeneration order comes in, the aircraft is pulled from its storage row and begins a systematic restoration process. The preservation coatings are removed. The aircraft is inspected in detail, every structural member, every system, every surface. Components that have degraded beyond serviceable limits are replaced. Engines are inspected and in many cases sent out for overhaul before being reinstalled. Avionics are checked, updated, or replaced as required. Hydraulic systems are purged and refilled. Fuel systems are inspected and treated. After all of that maintenance work is complete, the aircraft goes through a progressive return to flight, starting with systems checks on the ground and culminating in flight testing to verify that everything is working as required before the aircraft is delivered to its next operator. The timeline from pulling an aircraft out of storage to delivering it in a serviceable condition varies significantly depending on how long it was in storage, what condition it is in, and what standard it needs to meet. But some aircraft have been successfully regenerated after more than a decade in storage, which is a remarkable testament to both the desert environment and the quality of the preservation work that went into them when they arrived. There have been specific regeneration stories that stand out for their operational significance. During periods of high operational tempo, when the military is generating more sorties than the active fleet can sustain, or when unexpected losses require rapid replacement, AMARG has been the answer. In the years following the September 11 attacks, when American air power was being employed at a pace and intensity that strained available inventories, AMARG provided aircraft that helped meet the demand. Specific aircraft types that were needed in theater were pulled from storage, regenerated, and delivered to operational units faster than any procurement process could have provided new aircraft. This happened not once but repeatedly, and it happened because the strategic vision that created and maintained AMARG was sound. Keeping aircraft in serviceable storage in the desert is not sentiment, it is insurance. It is the physical manifestation of a strategic judgment that says the future is uncertain, demand is unpredictable, and having options preserved against that uncertainty has value. The people who made that judgment decades ago were right. Now let's talk about something that most discussions of AMARG leave out entirely, and that is the human dimension of what this facility represents for the people who fly military aircraft and the people who maintain them. For a maintenance technician, an aircraft is not an abstraction. It is a machine they know intimately. They know how it sounds when it is running right. They know the particular challenge of a specific system on a specific airframe. They know the history of the aircraft because the maintenance record tells that history in technical terms, but the technicians who worked on it day after day carry a more personal version of that history. When an aircraft they worked on goes to AMARG, there is something that happens to the people who knew it. Not grief exactly, but a recognition of a kind of ending. At the same time, the technicians who work at AMARG and who pull aircraft back out of storage and return them to service describe something that feels almost like the opposite. Bringing an aircraft back after years in the desert, hearing an engine run that has been cold for a decade, seeing something that was parked and silent become alive and functional again, that is described by the people who do it as genuinely satisfying work. There is meaning in preservation. There is meaning in restoration. And the people who do that work at AMARG understand it even if the broader public never thinks about them at all. Let's walk through what a day at AMARG actually looks like from the inside. Because the operational rhythm of the facility is interesting in ways that are easy to miss from the outside. The facility operates on a standard government workday, Monday through Friday, because the aircraft are not going anywhere urgent and the work, while important, does not require the around-the-clock tempo of an operational military installation. But within that workday, there is a remarkable diversity of activities happening simultaneously. In one section of the facility, a team is preparing an aircraft for long-term storage, carefully sealing systems and applying protective coatings according to a detailed technical process that has been refined over decades. In another section, a different team is doing the opposite, stripping preservation coatings from an aircraft that has just been selected for regeneration, beginning the systematic inspection process that will determine exactly how much work the aircraft needs before it can fly again. In the parts inventory area, technicians are removing specific components from designated donor aircraft, working from work orders that came in from operational units that need those parts today. In the administrative areas, program managers are working through the paperwork, the tracking systems, the coordination with customer organizations, and the inventory management that keeps the whole operation functioning. And somewhere in the facility, somebody is making decisions about a new arrival, an aircraft that just landed or was just delivered, assessing its condition and working through the system to determine what category it goes into and what its immediate next steps are. All of that is happening simultaneously, every workday, driven by a workforce of 550 people managing an inventory worth hundreds of billions of dollars. The ratio of people to asset value at AMARG is genuinely unlike almost anything else in the U.S. government. There is another aspect of AMARG that rarely gets discussed, and that is its role in treaty compliance verification. The United States has been party to various arms control agreements over the years that have required the verified elimination of specific weapon systems. For aircraft, elimination typically means that the aircraft must be physically destroyed in a way that can be verified, often by satellite imagery, which means the destruction must happen in the open and must be observable. AMARG has been the location where treaty-required aircraft eliminations have been carried out. The B-52s that needed to be eliminated under strategic arms agreements were cut up at Davis-Monthan, with the cuts made in specific ways and the pieces left in place for a period of time to allow satellite verification of the elimination. This function of AMARG connects the facility directly to the highest levels of American strategic policy. The decisions about which aircraft to eliminate, when to eliminate them, and how to document and verify the elimination process are made at levels far above the facility itself. But AMARG is where those decisions become physical reality, where a multi-hundred-million-dollar strategic bomber is reduced to verified scrap in compliance with an international legal commitment. That is a role that requires precision, documentation, and coordination with national-level policy processes, and it is one more dimension of the facility's importance that most people never think about. The aircraft that perhaps best represents the full range of what AMARG means is the B-52 Stratofortress, and it is worth spending time on this particular aircraft because its history and its current situation at the Boneyard is genuinely remarkable. The B-52 first flew in 1952. It entered service in 1955. It dropped bombs in Vietnam, in the Gulf War, in Afghanistan, in Iraq, and in Syria. It is currently projected to remain in service into the 2050s. No other combat aircraft in history has served with a single air force for a century, and the B-52 is on track to do exactly that. Over the decades, hundreds of B-52s were built. Today, a much smaller number remain in operational service, and a significant number sit at AMARG in various states and categories. Some are in long-term storage under treaty requirements. Some have been used for parts to support the operational fleet. Some have been cut up under strategic arms agreements, and some, remarkably, have been considered for potential return to service as the Air Force grapples with questions about future bomber force structure and the capabilities it will need to meet emerging threats. The B-52 at AMARG is not just an old airplane sitting in the desert. It is a physical asset in an ongoing strategic calculation about the future of American nuclear and conventional air power. The fact that well-maintained B-52s can sit in the Arizona desert for years and then be pulled out, refurbished, and returned to operational service is not just interesting trivia. It is a real and active part of how American military power is managed and projected. One story from AMARG's history that illustrates the facility's strategic value with particular clarity involves the A-10 Thunderbolt II. The A-10 has faced retirement proposals repeatedly over the past 2 decades, always driven by budget pressure and the Air Force's desire to focus resources on next-generation platforms. Each time a retirement proposal has been advanced, opponents of the plan, including many Army commanders who rely on the A-10 for close air support, have pushed back hard. The political and bureaucratic battles over the A-10 have been fierce and prolonged. Throughout all of those battles, AMARG has held A-10s in storage. The existence of those stored aircraft has been a real factor in the debate, because it means that decisions about the A-10 fleet size and composition are not necessarily permanent. If the Air Force retires A-10s to AMARG and the strategic calculus later changes, and a future Secretary of Defense decides the country needs more A-10s in active service, those aircraft can be brought back. The reversibility that AMARG provides creates policy flexibility that would not exist if retired aircraft were simply destroyed. That flexibility has direct value. It changes the nature of force structure decisions in ways that make the decisions less irreversible, and therefore easier to make in a direction that the current strategic situation requires without closing off options that the future strategic situation might demand. This is sophisticated strategic thinking embedded in what looks from the outside like a straightforward storage operation. Let's talk about the economics of AMARG in more detail, because the numbers are striking. The United States spends roughly $60 to $80 million per year to operate AMARG. That sounds like a significant sum until you set it against what the facility provides. The parts that AMARG delivers to operational users every year are valued at hundreds of millions of dollars. Some years, the parts value delivered has reportedly approached $1 billion. Against an operating cost of 60 to 80 million, that represents an extraordinary return on investment by any measure. But the economic case for AMARG goes beyond the annual parts value calculation. Consider what it would cost to replace the aircraft currently in storage if they were needed and did not exist. A new F-16 costs somewhere in the $25 to $45 million range depending on configuration. An F-15 costs more. A B-52, though no longer in production, would cost hundreds of millions of dollars to produce if production were restarted from scratch, which would require rebuilding an entire production infrastructure that no longer exists. The strategic reserve of aircraft sitting at AMARG represents production capacity that cannot simply be recreated on demand. Building a new fighter aircraft from a standing start, where no production line exists and the industrial supply chain has to be reconstructed, takes years and costs far more than pulling an aircraft from desert storage and refurbishing it. AMARG preserves not just the aircraft themselves but the operational utility that those aircraft represent, in a form that can be accessed relatively quickly and at a fraction of new build cost. That is an extraordinary economic asset, and it is one that the United States has maintained consistently through changing administrations, changing budget environments, and changing strategic priorities because the fundamental logic behind it has proven itself over and over again. The international dimension of AMARG deserves more attention than it usually receives. When people think about American military power, they tend to think about the weapons systems themselves, the aircraft and ships and missiles. What they think about less is the infrastructure that enables and sustains those systems over time. AMARG is part of that infrastructure. And its reach extends far beyond American borders. The aircraft that have left AMARG and entered service with foreign operators are flying in air forces on every inhabited continent. The parts that AMARG provides flow into international supply chains that support American-built aircraft operated by dozens of allies and partners. The maintenance knowledge and practices that AMARG has developed over decades are shared with partner nations through training programs and technical exchanges. American allies who operate American aircraft benefit directly from AMARG's existence even if they never send an aircraft there. When an ally's F-16 needs a part that is no longer in production, the American military's ability to locate that part in the AMARG inventory and get it into the partner nation's supply chain is part of what makes American military equipment valuable to allies. It is part of what makes countries choose American aircraft over competing products from other nations. AMARG is, in a real sense, a sales tool for American defense exports, because part of what buyers of American military equipment are buying is access to the long-term support infrastructure that only the United States has built and sustained at this scale. No other country on Earth has anything like AMARG, and the competitive advantage that creates for American defense exports is significant. Let's talk about the environmental side of AMARG, because it is a genuine consideration that the facility takes seriously. Aircraft are full of hazardous materials: hydraulic fluids, fuels, lubricants, battery chemicals, various specialty compounds used in avionics and structural applications. When aircraft are dismantled at the end of their service lives, the proper handling and disposal of these materials is both a legal requirement and an environmental responsibility. AMARG has developed procedures for managing these materials that meet applicable environmental standards, and the facility operates under environmental management requirements that have become more stringent over the years as regulations have evolved. The caliche soil that makes the site so ideal for aircraft storage also creates specific environmental responsibilities, because the hardpan surface means that spills and leaks do not simply drain away. They sit near the surface where they can affect groundwater if not managed properly. The facility takes this responsibility seriously, both because the law requires it and because Davis-Monthan Air Force Base has a long-term relationship with the local community in Tucson that the Air Force intends to maintain. The environmental management at AMARG is not glamorous work, but it is important work, and the people who do it are as essential to the facility's function as the technicians who maintain the aircraft. There is something philosophically interesting about what AMARG represents in the broader context of how human civilization relates to its technology. We build the most sophisticated, most expensive, most powerful machines that our engineering capability can produce. We operate them at the edge of what is physically possible. We push them through extreme environments, extreme stresses, extreme temperatures, extreme speeds. We entrust lives to them, and those machines carry those lives faithfully. And then we park them, In rows in the desert under the sun waiting, there is a kind of poetry to that if you choose to look at it that way. The aircraft at AMARG are not dead, they are suspended. They exist in a state that is neither operational nor destroyed. They are potential preserved against need. The F-16 sitting in row 42 section B of the AMARG storage area, cocooned and still, might be inert today. But it contains within its airframe the potential to fly again, to accelerate through the sound barrier, to carry weapons, to protect or to project power. That potential is what AMARG preserves, and that potential has real value, strategic value, financial value, and operational value that is difficult to put into a single number but impossible to dismiss. When visitors are allowed to see the facility, typically during air shows at Davis Monthan or through carefully arranged tour, the reaction is almost always the same. The scale defeats expectation. People have seen photographs, they have been told the numbers, and then they walk out onto the perimeter road and they look at the rows and the rows and the rows of aircraft, and the numbers stop being numbers and become something else, something that has physical weight. The sheer accumulation of engineering, of manufacturing, of national investment, of human effort, of operational history, all of it sitting there in the desert under the Arizona sun, silent and still and waiting. It is one of the genuinely awe-inspiring sights that the modern world offers, and most people never know it exists. Let's talk about what the future holds for AMARG, because the facility is not static. The nature of the aircraft inventory changes as the force structure evolves. As older types like the F-16 and A-10 are gradually phased out in favor of F-35 fifth-generation fighters, the composition of the AMARG storage inventory will shift. F-35s are already beginning to accumulate at the facility in modest numbers, and the logistical and maintenance challenges associated with a fifth-generation stealth aircraft are different in important ways from those associated with the fourth-generation platforms that have historically dominated the inventory. The F-35's advanced avionics, its stealth coatings, its integrated sensor systems, and its software-defined capabilities all create preservation challenges that are being worked through now. Stealth coatings are particularly challenging because the materials used in low-observable aircraft surfaces are sensitive to heat, moisture, and handling in ways that are different from conventional metal aircraft skins. The facility is adapting its procedures to accommodate these differences, developing new preservation methods specific to fifth-generation platforms and training its workforce in those methods. The future AMARG will look different from the current AMARG, and that evolution is already underway. There is also the question of unmanned aircraft, which are entering military service in growing numbers and will eventually flow through AMARG in significant quantities. The storage and preservation of unmanned systems presents different challenges than manned aircraft in some respects and similar challenges in others. The basic principles of desert preservation that apply to conventional aircraft also apply to unmanned platforms, but the specific materials, systems, and configurations involved require tailored approaches. AMARG is already working through these questions, and as the military's reliance on unmanned systems grows, the facility's role in managing the life cycle of those systems will become increasingly important. The fundamental mission, preserving military aviation capability against future need, will remain the same. The specific forms that capability takes will continue to evolve. There is something that everyone who has worked at AMARG or studied it carefully comes back to eventually, and it is the idea of stewardship. The people who work at AMARG are not glamorous figures in the military aviation world. They are not test pilots or fighter aces or carrier captains. They are maintenance technicians and program managers and logistics specialists and environmental compliance officers. They are government workers doing government work in a desert facility that most of the public has never heard of. But the work they do is stewardship in the deepest sense of the word. They are preserving capability that belongs not just to the current military, but to the nation's future. They are maintaining options that strategic and political leaders have not yet decided whether to exercise. They are keeping alive the possibility of responses to threats that have not yet materialized, in forms that cannot yet be fully specified. That is a remarkable kind of work. It requires discipline, precision, institutional knowledge, and a genuine understanding of why what you are doing matters even when the immediate operational urgency is not apparent. The aircraft that sit in those desert rows are not exciting. They are not flying. They are not doing anything dramatic. And yet they represent something important. They represent the decision made decades ago and renewed every year through budget allocations and policy choices to take seriously the idea that the future is uncertain and that preserving options for the future has real value. That decision and the facility it created and sustains have paid off many times over. They will pay off again. If you think about all of it together, the scale, the variety of aircraft, the multiple missions the facility serves, the economic value it generates, the strategic flexibility it preserves, the parts it delivers to operational units, the aircraft it regenerates and returns to service, the treaty compliance it enables, the foreign policy options it maintains, the environmental responsibilities it meets, and the workforce it requires to do all of this with 550 people across 2,600 acres, the picture that emerges is not of a graveyard at all. It is of a living institution. An institution that breathes slowly, that operates on timescales longer than most military operations, that measures its output in decades and in strategic options preserved rather than in sorties flown or targets destroyed. But an institution that is alive, that is working, and that matters.